All right, rookie, grab your coffee and listen up, because today in this explainer, we're going to cover how to protect our network without accidentally taking down the entire company. You've got the theory down, right? Well, now it's time to actually apply it in the real world.
Welcome to the server room. This is your new home. Just take a look around at all this hardware. Now, before you even think about touching a single live router in this facility, we are absolutely going to cover the bedrock of network security. Because honestly, a single misconfigured line of code can literally lock every employee out of their vital systems. We've got to get this right.
So, grab that notepad, because our agenda today is packed with 5 crucial concepts. We're covering the router's bouncer, first match logic, standard ACLs and wildcards, the dreaded implicit deny trap, and finally, placement and direction strategies.
Let's jump straight into Section 1, the router's bouncer, which is all about how we control the flow of traffic. I want to start by asking you the most fundamental question. How do we actually tell our routers which traffic to trust and which to kick out? Because out of the box, a router's only job is just to route. It wants to forward everything. We have to give it a specific set of rules to tell it otherwise. And that brings us to our core definition. An access control list, or ACL, is basically an IPv4 packet filter programmed right into the router. Think of it exactly like a VIP bouncer at an exclusive nightclub. The ACL sits right there in the forwarding path, carefully inspecting the arriving packets, checking their IDs, or in this case, their headers, and then making a split-second decision on who gets permitted inside and who gets tossed to the curb. See, every single physical connection point in this room is an opportunity for security. You have to apply an ACL to a specific interface and, crucially, choose a specific direction. You can apply it inbound, which means the router checks the packet before making any routing decision at all, or you can apply it outbound, catching the packet right as it's trying to leave the interface. Location and direction are the whole shebang here. Okay, moving right along to Section 2, first match list logic. This is all about how the router actually processes the rules you give it. The biggest thing to grasp here is exactly how an ACL is read. It is a strictly sequential list. A router reads it from top to bottom. In Step 1, it checks the incoming packet against the very first line of your ACL. Step 2, if it finds a match, it takes the configured action, either permit or deny, and then it completely stops reading the rest of the list. Done. Step 3, only if absolutely no match is found does it move down to the next line and repeat the process.
I literally cannot emphasize this enough. First match wins. This right here is where so many entry-level engineers totally mess up. If you put a broad, sweeping rule at the very top of your list, the router is going to trigger on that immediately. It will never, ever even see the more specific rules you so carefully typed out underneath it. So order of operations is absolutely everything.
Let's transition into Section 3, standard ACLs and wildcards, where we'll actually look at writing the syntax. Now, there are a few different types of ACLs, but today you are learning standard numbered ACLs. These are traditionally numbered between 1 and 99. Here's the catch, though. Standard ACLs are super simple, but they're incredibly limited. Why? Because they literally do not care where a packet is going. They cannot filter based on the destination. They solely look at where the packet came from, the source IP address. That is their one defining characteristic. So to make these work, we have to talk about the wildcard mask. When we write our ACLs, we use this neat little 32-bit math trick to tell the router exactly how strictly to look at an IP address. You can think of it as the exact inverse of a subnet mask. In wildcard math, a binary 0 demands a strict, exact match of that specific bit. But a binary 1? That tells the router to completely ignore that part of the address. It's a wildcard. Let's translate that math into the actual command line. If you just type the IP address 10.1.1.1, you're permitting just that one specific computer. Simple, right? But if we use a wildcard mask ending in 255, which is all binary ones, we're telling the router to match the first 3 octets exactly, but totally ignore the last one. Just like that, boom, you've denied an entire subnet of 244 hosts from accessing your network with just a single line of code. Pretty powerful stuff. All right, on to Section 4, the implicit deny trap. This is the invisible rule that breaks absolutely everything. Listen very closely to me, rookie, because this right here is exactly how you bring a network to its knees.
If you write an ACL and a packet travels all the way down your list without batching any of your specific statements, it doesn't just get a free pass. No way. There is an invisible, totally implied deny all rule baked right into the very bottom of every single list. If no match is made, your packet is mercilessly discarded into the void. Boof, gone. So, how do we avoid taking down a whole department just because you forgot to account for their traffic? You have to intentionally override that invisible trapdoor. You do this by adding an explicit permit any statement to the very end of your script. This basically ensures that any traffic that didn't match your specific deny rules is still allowed to flow freely through the router.
Finally, let's wrap up with Section 5, Placement and Direction Strategies, because honestly, having a great script means absolutely nothing if you deploy it on the wrong interface.
Remember earlier when I told you standard ACLs only filter based on the source address? Because of that huge limitation, we have a golden rule. You must place standard ACLs as close to the destination as possible. Think about it. If you place a standard ACL too close to the source and you block their IP, you won't just block them from the one server you meant to protect, you're going to accidentally block that source computer from reaching absolutely anything else on the entire network. Let's map this onto a real corporate network so you can visualize it. Say we want to block the generic workers on the 3.0 network from reaching the HR server. We do not put the ACL way down near the workers. Instead, we apply our ACL inbound on Ethernet 0/2. That's the interface directly facing that destination HR server. By doing it this way, the workers are blocked from HR, but they can still freely browse the internet out of the serial interface. Make sense?
Okay, before I let you go touch the live equipment, let's do a quick survival checklist. Make sure these core axioms are hammered into your brain. Standard ACLs only care about the source IP. You have to apply them to an interface, either inbound or outbound. The router reads them top to bottom, and first match always wins. For wildcards, 0 means match, 1 means ignore. Standard rules always go near the destination. And please never, ever forget that invisible, implicit deny waiting at the bottom of your list. So, armed with all this knowledge of wildcards, implicit denies, and bouncer logic, you literally hold the keys to the kingdom now. You have the power to tightly secure our infrastructure or completely isolate it by accident. So, the only question I have left for you, rookie, are you ready to write your first access control list?